The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone, and welcome to our webinar this week. My name is Tanya, and I'm the Marketing Manager over here at Truss Solutions. Just for those of you who are new with us today, MWF, or Metalwood Framer, is our automated Revit wall, floor, ceiling, and truss framing software for light gauge steel and also wood modeling. Everest, however, allows the user to easily engineer light gauge steel trusses outside the Revit and MWF environment. So with that said, today's session, which will be hosted by our senior technician, Christina, will cover Everest, including how to create custom profiles, how to customize member sizes, webbing and load settings, how to engineer trusses, view analysis diagrams, and finally create detailed reports. Just before we get going, I want to remind everyone that at the end of the webinar, we'll be taking a few live questions. In order to be selected, please press the raise hand button on the dashboard. Just please also make sure that your mic is working correctly. If you'd prefer, you can also ask questions throughout the webinar in the questions tab of the GoToWebinar dashboard. Those questions will be answered as soon as possible. Some might even be answered during the webinar. All right, that's it for me. I'll hand off to Christina now.
All right, thanks, Tanya. So good afternoon, everyone. Welcome to today's webinar. So as Tanya mentioned, for today, we're going to exclusively look at the Everest software. So is anyone who's familiar with the MWF Advanced Metal Truss Design, this is basically a standalone version of our Truss Designer. So the purpose of this is just going to create the trusses, you can customize the webbing, and then we'll be able to run analysis and get those same PDF reports and produce those by the end of today. So let's start off with the basics. And since obviously we're not in Revit anymore, we just first have to start creating our truss profiles. So we'll give you 3 basic truss profiles to choose from that you can start customizing. So there's your basic pentagon shape, which you can use your common trusses. And this is where you'd put in the width, the height, the overhang on each side. There's the quadrilateral shape. So if you want to use this for floor trusses, flat roof trusses, could also customize this, use this for jacks. And then for your hips, you can go ahead and use the hexagon shape. So I'm going to keep it pretty simple for today. We're going to use this quadrilateral shape. And for the width, I'm going to put in 10 feet. And then you can control the height of each heel. So let's make this a bit more interesting. So I'll do 2 feet on the left side, and then maybe I want to do 3.5 on the right side. So anyone, again, who's used the Truss software a little bit, the same kind of workflow is still applied. So to input things in inches, you're just going to use the dashes, and I've got 3 feet, 6 inches, and then your last value is just to a 1/16 of an inch. So go ahead and hit create, and then you'll just get kind of the basic profile to start off. So again, this is pretty much identical to the Truss Designer that we have in Advanced Metal. So to start off, you'll notice there are the nodes. And if you double click on the nodes, they can have a few functions. They can act as supports, first and foremost. So we put everything by default as a pinned roller support at the beginning. We defaulted to 6 inches as well. Assume that the heels are going to sit on center of these supports, but these are always things that you can modify in here. So we can change the width, change the fixation, and change the alignment. The other thing that you can do with these nodes as well is also insert point loads. So if you did want to add any additional dead and live point loads, you can consider wind as well and pop those in directly with the node. So where you can where it can come in handy with these nodes are that you could also place them freely throughout the truss. So if you did have maybe some kind of interior bearing support that you wanted to consider, or if we wanted to put point loads anywhere on this top chord, you've got these options off to the side here to add in your own nodes. So the nodes you'll see here kind of work in like an XY coordinate system. So simple enough to set these up. So let's do that example. If I did want to place one dead center, add an extra support there, I can come to my command over here. I'm just going to place this at 5 feet, hit the coordinates button, and it'll give me that extra node at the midpoint. So I can double click on it, convert it to a support type, and you get your extra middle bearing support with one of these nodes. But this was obviously a pretty simple example. Let's say we did want to add a point load somewhere on this top chord, and I don't want to have to start calculating that Y coordinate. I don't want to start doing geometry. Then you can use this on member point option instead, which is basically where you can base one node off of an existing one. So I'm just clicking on my line, which runs from node 3 to 4. I'm base this off of node 5. And let's say I know my point load pretty much is going to hit dead center between these two supports. So I can put in that distance, 2.5 feet, and I'm going to go ahead and hit horizontal. So basically what that does is it moves it 2.5 feet, and wherever it lands on that line, just adds in the extra node automatically. So I didn't have to start figuring out what that Y coordinate was. Can go ahead and add in the point load. Maybe I'll just put in, let's just say 10 pounds. And once you have that extra point load in, you'll see that extra purple ring around your node, just to designate that there's a point load there. So that's how the nodes can work essentially. This will also come in super handy later on when we get into the webbing a bit more. We'll get into, but you can pretty much move them in any which way. If you're moving it in the opposite direction, so kind of in the negative direction, you could also just put in a negative value and it'll pop it the other way. So simple enough just to get your node set up. So now let's finally get into the webbing and some of the settings. So you can hit generate web right out of the gate and it'll populate with some pretty generic webbing. So we can go to the settings, and again, anyone who's seen advanced metal a little bit, these are the exact same truss designer settings and the bulk of the options that you'll have for the trusses. So this is where you can start setting up your truss types. If you're dealing with wall trusses, which just bends about the weak axis, or if you're dealing with back-to-back, which bends about the strong axis, your truss category, the units as well, if you want to switch to millimeters, the webbing type, which we'll get into, and then if you did want to give the truss an actual name, so you can identify this later on in the PDF. It's also something you at this point. So these are just some of the general options. And the other thing as well is that you could always save these files. So if you're reusing a lot of the same designer settings, you could always save it. It'll save it as an XML file, and you could always bring it back into Everest. So those are the general settings. And now we can finally talk a little bit about the webbing. So by default, we've got our webbing basically set up at equal intersections. So I have it set to be maxed out at 4 feet. And basically what this does just looks at the length of your truss and kind of breaks up the truss into equal bays according to that maximum. So if you did want more webbing, if you did want to play around with the spacing a little bit, you could always come in here, input these values. Maybe I can switch it to 5 feet, say okay, and then just regenerate your webbing according to that max. It'll recalculate how many members you need. So this is one option. And I'll also just highlight these 2 check boxes where if we did have that extra middle support, or if I did put in back my point loads, I can get some verticals automatically at those points. So if I take this existing one and convert it, let's clear out the webbing, regenerate it, get an extra vertical at that point automatically, and it'll base my spacing from that point as well. So this is one option that you have for the webbing. At this point, I'll also point out that you can always manipulate your webbing with the nodes. So if you did want a bit of a top chord overhang, if you're lapping these onto your hip trusses, you want to bring in your heels a little bit. We do have this left and right heel offset, but what I actually prefer personally is just to delete this member. So just hit delete with your keyboard. And then using these commands again, I can just create some new nodes. So maybe again, I'll base it, let's base it a foot off of node 2. There we go. I think I did 10 feet by accident. Oh, let's say offset by. That was my mistake. So since I'm basing it off of node 2, I'm going to put a -1, say offset by, and it just places it a foot off of node 2. So then again, maybe I want a node directly above node 11. I'm going to switch the on-mem point, base it off of node 11. And instead of putting some kind of distance, I can leave it to 0, hit horizontal. So it's not moving anywhere horizontally, and it's going to place directly above node 11. So that's a nice little cheat that I like to use sometimes. If I know I want a node directly above one that exists, and if it's sloping. So this is where you can start clicking from node to node. So if I left click one node and right click to another, I can create my own webbing. And it'll fill in the members when you double click the line. And you can give it a designation. So this guy here will be a diagonal web. At this point, I also have the option to change the member size if I want to, but we'll get into that with the pick lists. And this one can be my heel. So you always have the option if you are dealing with maybe some funkier trusses that don't have just the basic generic webbing. You can always create your own, delete, and redraw your webbing if you need to. So this is one option that you have for the webbing. But I'll show you finally what is probably the second most commonly used option, which is diagonals only. So if you only want to frame with diagonals, which is exactly as it sounds, I can switch my vertical positions to only have diagonals. And then when I go ahead and regenerate my webbing, it's only going to place diagonal members. This is where your webbing type in that general tab can come in handy too. If you want your diagonal to start off with the other orientation, just flip your webbing types and regenerate your webbing. So the only other options that you can control for the diagonals, again, to control the amount of webbing you have, you can put in your maximum bay width over here. So maybe I'll bring this down to 5 so I can get some more webbing. And also, we do break diagonals at the bottom chord to give you some wiggle room between the two members. It's defaulted to 6 feet or 6 inches. 6 feet would be a bit much, but it's defaulted to 6 inches, and you could always bring that down a little bit more. So then it'll look something like that. The last option really in here is just to consider some kind of track thickness. So we'll see when we get into some more of the physical member options that you'll be able to see physically how these trusses are going to be assembled. Okay, so that's it for kind of our standard webbing options. I'm going to switch it back to have equal intersections. And let's get into the member sizing. So one of the things with Everest, kind of self-explanatory, but still nice, is that since we're not in Revit anymore, there's no families to load in, there's none of that information. Every single member size that we have is going to be listed automatically. So we'll have the typical standard ones, the S truss, the T truss. We do have some cap and brace options. If you want to strengthen your top and bottom chords a bit, you could always switch it out to be one of these doubled members. But just want to highlight, there's no need to load anything in Everest. It's always going to come preloaded. It also does make it quite a bit simpler if ever there's any new sizes that you want to add into the software. It's pretty easily implemented. There's no more families to be created. So we can add it to the software pretty quickly. All right. So in terms of the analysis, works exactly the same way as advanced metal, and it just works by pick list. So how our designer works is that according to this list, it's going to look at your webbing, your loading that you've inputted, and then according to all this information, it's going to tell you if the size passes or fails. So if I do hit design, I can basically just have it run through this list and try and find an appropriate size. So maybe let me clean up this list a little bit. So obviously only limit it to the sizes that you're going to be using. So maybe I'll just stick to a few 362s, and I could always just shift click delete everything that I don't use, and clean up my list a little bit. Just hit apply to all, and it's copied to all of your different member types. So of course, if you do start adding in new sizes, or if you delete something accidentally, you can come back to this add button over here and you'll get the access to the catalog again. Just re-add the sizes that you need. So I'll give 3 kind of standard sizes. Again, you could differentiate it by member type if you wanted to use some beefier options, if you wanted to cap or brace your top and bottom chords. And in the webbing and the heels, you do always have the option to create bracing. So you can have one at the midpoint, you can create one every 3rd point, and it'll be added to the bottom of the pick list. You can always, of course, move this priority list around. And basically, it's just going to consider some lateral bracing during the analysis. Okay, so I'm good with these member sizes. Now let's move on to the physical member. And the physical member is just a way that you can control how the truss is going to look. It's, again, something we've brought in from the Revit side of the software, but it can still give you a good idea on how that truss is going to be assembled. So for this, you could switch to the physical view, and you'll actually be able to see how these members are going to lap, what gap is between the webs. And if you did ever want to control this a little bit more, you can choose some of these physical member options. So a good example, if I maybe wanted some extra spacing between all of my web members, I can add 6/16 of an inch. And this will be a subtle change, but you'll actually see the webs get a bit more farther apart. So it's just handy for some extra visuals so you can see the webbing. Other thing, if you do have common trusses, of course, anything triangular, you could always lap your top chords. And at the top here, like I mentioned, we always do consider some kind of track thickness. It's set to 1/16 of an inch, but you could always increase that a little bit more. We maxed it out at 9, so let me switch that back. And bit of a big gap, but if ever you want to give yourself a bit more clearance to your top and bottom chords, change that insertion thickness. So 9 is a bit much. I'm going to bring this back down to 1. So moving past that, let's get into the designer preferences, which are super simple. When you go back to the line view, if you want to make your nodes a little bigger or your lines thicker so they're a bit easier to see, then you could always just come in here and adjust the node size. It'll make them a little bit easier to grab, especially if you're adding point loads or webbing your own trusses. But then that finally brings us to the engineering tab, which is where you're going to input all of your loads, where you choose your building code, and where you'll put in all of that information. So like I mentioned, the standard loads are all applied through here. So your live loading, your dead loading, you can customize those values. You can put in the spacing of how far apart these trusses are going to be spaced. If your top or bottom chord spacing is sheathed or purlined, you can adjust the purlin spacing. But main thing I did want to address is that we did now add LRFD to the designer. So before we're only on ASD, so you do have that option available now in the code. Besides that though, some things are a little different. You can choose different CSI values now. So if you did want to disable some of these options, they won't be considered during the analysis, but your CSI limits are still the same. You can still change your overall model, and you still have the option of choosing a screw category, and we'll give you an estimated number of screws in the reports. Besides that, deflection, still exactly the same as it was before. You can put in your own values. The wind and snow loading as well, not too much has changed in here. You can always turn these settings on and off. But of course, since we're not in Revit, you do just have to input the pitch that this truss will be and kind of the max and min plan dimensions of the roof it's going to go into, as well as just the average roof height. So I'm just going to bring these down a little bit since it's a little large. And for the wind load, you could always consider the components and cladding. Snow loading, pretty much exactly the same thing. I've turned mine off in this case, but it's the same idea. You can adjust the category for the risk, the terrain category. So all these things can be adjusted. This other option, it's available if you want to add in wind and seismic drag. We added this option in a while ago, but it's in pounds per linear foot. We have it turned off by default, but you can always activate them and input your own values. Last option for the combinations. So for your load combinations, something newer that we've added in, you could always customize which load combinations you want to consider. If you only want to run it for dead and live load, then you can unselect everything else. But I do also just want to show that in your installation folder, if you go to your C drive, go to your Struxsoft Solutions, in the Everest folder, you'll actually be able to see all the load combinations in an Excel format. So if I double click on the ASD, these are all the load combinations that are going to be run. So if ever you did want to come in, adjust some of these values, you could always adjust that in the Excel. So that's it for the majority of the engineering options. The last tab in here is just to generate the reports. And again, we do generate 3 basic reports. There's going to be your fabrication drawing, the engineering drawing, and then a more detailed version. So you can come in, put your company information. It's going to be printed on the PDF. And that's essentially it for the settings. At this point now, I'm just going to stick with my pretty generic webbing, and we can go ahead and actually run analysis. So what I'm going to do first is actually select the diagrams. And the diagrams basically does 2 things. It's going to run the analysis at the same time and also populate the diagrams. So we'll be able to see the moment diagrams, the deflection, the shear. And it's going to just look at the first member on my list and tell me if it passes or fails. So you'll be able to see all your different load combinations. I can turn on the envelope version just to see all the combinations in one shot. And the other thing that can be helpful, if ever it is failing, it'll show you your CSI values. So anything that is failing, the area will highlight in red, and you'll be able to see that in the diagram. What I also consider probably the most helpful thing is that you can always show details, and it shows the individual analysis points along the truss. So you can double click on any one of these dots and it gives you a full load summary at that point. So once I close out of my diagrams, that 362 that I had on my list first did in fact pass. You could always switch to the analysis view. Everything's green, so we're good to go. But if ever it was failing, you could always hit design, and what design again is going to do is just run through that list and try and find member sizes that will pass. Once everything is good to go, we can generate our PDF reports. And if we take a look at the fabrication one first, simple enough. It gives you your material, the estimated screw count. So it'll give you an estimated total. Right now we do have the limit set to 2, but we are going to make it available so that you can select 2 or 4 as your minimum. And then we also did add kind of a landscape version, which is just going to make it a little easier on the eyes to read for all the dimensioning, and the numbers in the circles are again just your screw count. So these numbers as well are the nodes, which is just one way how we label our webs. They'll just be from node 1 to node 3. The next one, which is just the engineering report, something we tried to keep down to a page. So just to give you a general summary. So it'll just give you a load summary, your CSIs, the deflections, and just your member forces summary. And finally, the detailed one is where you'll get more information. So you'll have the reactions at every single point. So general summary up here as well. It'll give you your truss naming, the truss type, also gives you the weight of the truss, so that's incorporated in the PDFs. So I think that's a nice little summary of Everest. So that's going to be it for me today, guys. As Tanya mentioned at the beginning, if you do have any questions, feel free to go ahead and ask them now.
Awesome. Thank you, Christina. Just want to remind you that if you would like to pose a question live, please raise your hand now by clicking on the hand icon in the control panel. Just please also make sure that your computer audio is working correctly. Just while we wait for any questions to come through, I'd just like to remind everyone again that the recording of the webinar will be sent through shortly. As always, please feel free to share this recording with any colleagues. And if you'd like to set up a one-on-one demonstration or have any follow-up questions, we highly encourage you to reach out to our team. Contact details for our sales team will be provided with the recording. All right, I'm just going to give it a couple of seconds to see if there are any questions. All right, it looks like there's one from Alex. Alex, I'm going to go ahead and unmute you. All right, go ahead, Alex.
Hey, can y'all hear me?
Yeah, I can hear you.
Oh, perfect. Just had a quick question for the, you mentioned there's a member type option of a cap, a brace, and a double if we need like a heftier top cord or bottom cord. What are the difference between those, the cap, the brace, and the double? Is it just the shape of it?
Yeah, that's it. So the cap will actually have the open face overlapping. The doubled one, I believe, will orient them back to back. So it's just how the members are oriented and depending on which truss you have.
Gotcha. Okay. And those are just similar to the normal studs. They'll have the different size, like 362. Okay, I see it now.
That's exactly it. We actually have the families in Revit. If you want, Alex, I can send those to you. So if you want to see how they look in person, I can send those over. But yeah, that's exactly it. It's just doubled up members and they're capped back to back, just oriented differently.
Okay, perfect. Yeah, that would be awesome. Basically, I just had that question, and the only other one, will Everest do like a step truss? You know, if there's ever like at the end of the bearing of a truss, sometimes the beam sticks up into the truss, or maybe there's like a architectural need for like a, step inside of the truss. Is that something that's doable on here as well?
Yeah. So again, for the templates themselves, they're pretty basic, but I think you're pretty used to the designer by now, so it's exactly the same thing. So you just can actually delete the member out, move the nodes around, click from node to node. So it's exactly the same thing as the designer.
Okay, just draw it out. Okay, gotcha. Perfect. Well, I think that's all my questions. Thank you.
No worries.
Awesome. We'll just give it a couple more seconds to see if there are any other questions. All right. Well, that seems like it's a wrap for today. For any follow-up questions, as I mentioned before, please feel free to shoot us a quick email. We're happy to get back to you as soon as possible. Once again, I just want to say thank you to Christina and thank you to everyone who registered for the webinar. All right, we'll now be ending the webinar. Thank you very much. Have a great day.